Okay, so we're going to do hydrolysis. This is number 36 on your notes. And just to kind of introduce it a little bit, remember when we just had pure water and it had auto-ionization and it would break down into hydronium ions and hydroxide ions, and it was 1 times 10 to the negative 7 of each, right? Okay, so that made the two concentrations the same and you just said it was neutral. All right. If you added an acid to it, like HCl, the HCl is a source of hydrogen ions. And the hydrogen ions being added made the reaction shift that way, the equilibrium, right? And that meant that there would be now fewer hydroxide ions, you'd have less than before, but you still have more hydrogen ions than before because you added some. So even though it shifted to the left, you still have extra. And so it becomes an acid. All right, if you added a base, then you were adding hydroxide ions, which shifts the reaction this way. That means that there's less hydrogen ions, but there's still more hydroxide ions because you put more in before it shifted. That all makes sense, right? So water's neutral, add an acid, becomes acidic, add a base, becomes basic, okay? What happens if you add a salt? Okay, so that's the new thing we're going to do. Hydrolysis has to do with what happens if you add a salt to water. Okay, so if you guys remember from before, you make salts by acid-base reactions, and if you wanted to make NaCl, oops, I wasn't going to show that, what acid and base would you add? NaOH. And HCl, right? You would add a base containing the cation and an acid containing the anion, okay? So this is the cation of the base, this is the anion of the acid. I'm going to use a lot of words that you know what they mean, only I'm going to say a whole bunch of them close together and it starts to get a little confusing. Okay, so I'm going to be saying things like the cation of the base of a weak base or the anion of a weak acid. And so that's why I kind of want to remind you what I'm talking about. All right, if you take a salt and you put it in water, what we're trying to figure out is how will that affect the pH, dissolving a salt in water. Okay, when you put a salt in water, if it's soluble, it'll break down 100%. So we're going to make that assumption. And then each of these ions would be floating around in the water, and we have to figure out how that's going to change the hydrogen ion or the hydroxide ion concentration, and that's what's going to make it be either acidic or basic or neutral. Okay, so that's kind of a big idea of where we're going with this stuff. Okay, so what is hydrolysis? Okay, you guys should, oops, this is very sharp. Okay, it's the dissolving of a salt. Thanks. Dissolving of a salt in water to produce an acidic or basic solution by altering, and then it's either going to alter the hydronium ion concentration or the hydroxide ion concentration. Okay, so you can look at a salt's formula and you'll be able to figure this out eventually. This is going to be like a summary of the whole thing, and then I'm going to show some specific examples of it. Okay, so if you take a cation of a weak base, it will hydrolyze, which really means it will react with water to make an acidic solution. And if you add the anion of a weak acid, it will hydrolyze or react with water to make a basic solution. Okay, so just to remind you, if you have a salt, it's usually going to be, because you put an acid and a base together, and you'll have two parts to the salt. You'll have the cation from the base, and you'll have the anion, from the, well, I guess that's okay, from the acid. Okay? So let's try to figure this out. This is one of those topics where I'll have to do a few before you'll understand what's going on exactly. Find another sharp pencil because this one's annoying. They're all like that. Okay. So let's say that I take some pure water and then I put some KCl in it. Okay, KCl is a soluble salt. And as soon as I put it in water, it'll break down into potassium ions and chloride ions. Since it's soluble, it'll be 100% ionized. Okay? Whether or not this makes it an acidic or basic or neutral solution has to do with whether either of these ions will react with water to make an acid or a base. Okay, so like let's say that I tried to figure out what would happen with the potassium ion in the water. If the potassium ion reacted with water, since that's positive, it would kick out a hydrogen in the front there. It would make KOH, and it would make hydrogen ions. Okay. Is this a strong base or a weak base, KOH? Okay. So what do you know about strong bases? They're 100% ionized, which means it would immediately break right back down into potassium and hydroxide. In other words, this would not happen. Okay, the potassium ions would not react with water to make KOH and hydrogen ions because this would not form molecules of KOH. It would immediately break back down again. So since it's making a strong base, there would be no reaction at all. So there would be no hydrolysis. And since there's no hydrolysis, it would just stay as potassium ions and hydroxide ions. I wouldn't have changed the concentration of either hydrogen ions or hydroxide ions in the water. Does that make sense? If I add chloride ions to the water, since that's a negative thing, it would react with the H+, and it would go like that, right? What do you know about HCl, strong or weak? Okay, so what would this do? It would immediately break down into hydrogen ions and chloride ions. So in other words, this wouldn't happen either, okay? There would be no hydrolysis for this one. Since neither ion that is dissolved in the or that came from the salt would react with water, that would not change the concentration of hydrogen or hydroxide ions in the water, and the thing would be neutral. It would still have just the same amount as before. Therefore, the hydroxide ion is still equal to the hydrogen ion, really hydronium, and it's still neutral. And you would expect the pH to be 7. So if you dissolve KCl in water, it should be a neutral solution. All right, let's try a different one.